So within the embryology series, this is the third question that we are looking into. Again, as we see, it is one of the most paramount things that you see in embryology, the second week of development of the embryo, something that is frequently asked, and you should know the when it comes to embryology, the timeline is something that you should remember, because it's always the timeline as well as what are the changes that happens in the embryo is the things that are being asked. So make sure that you know the timeline and how what are the changes that are taking place. So this is about the second week. We'll look at the second week, what changes that takes place. So initially at the completion of the first week, with and the initiation of the second week, the implantation takes place. Implantation is a process where you see the blastocyst getting embedded onto the posterior upper half of the uterus. If it is the uteri involved, then there are no complications, but if it is outside that of the uterus, then there is a possibility that it could be an ectopic pregnancy. But in some ectopic pregnancies, if it is particularly found in the infundibulum of the fallopian tube, it passes down and gets back to the position where it should be. So the implantation takes place. At this time, what you see is a ball of cells with a cell covering that is present to the edge, which is known as the trophoblast. That is important in formation of the extra embryonic tissues, which is the placenta. And then there's another few cells which are known as the embryoblast. What happens is that the embryoblast in the second week will form a bilaminar structure. This bilaminar structure is composed of epiblast dorsally and the hyperblast underneath. So these two layers forms the bilaminar structure. Then in the epiblast in the second week, there is the formation of the primitive streak. If we illustrate the embryo to be of this structure, now if I look at this in a more as a cross section, what I would see is the presence of two cell layers. There's the epiblast and then there's the hyperblast. You see a sort of a cleft-like structure that is forming on the dorsal aspect. In the dorsal aspect, that furrows in from the epiblast to the hyperblast. There are cells that are passing from the epiblast and moving into the layers that is present between these two consecutive layers. This is involved in the formation of the three layers that forms the three-layered structure that forms the ectoderm, the mesoderm, as well as the endoderm. So in fact, these three germinative layers that are formed after the second week or within the third week is formed by the cells that are migrating from the epiblast or the dorsal layer. It migrates from the structure which is known as the primitive streak. The pole of the primitive streak or the caudal end, the cranial end consists of a node which is known as the primitive node. The primitive node is, as well as the primitive streak, is important in orientation of the embryo in the craniocaudal direction. The primitive node depicts the cranial region, and the latter, or the distal part of the primitive streak, shows the caudal region. So with the the bilaminar formation, the primitive node as the primitive streak, all of these structures forms within the second week. Then of course, at the starting of the third week, you see a trilaminar or a three-layer structure. Trilaminar layer, right? Furthermore, in the second week, you see that the trophoblast starts to differentiate as well. The trophoblast forms two layers, the syncytiotrophoblast as well as the cytotrophoblast. The syncytiotrophoblast is present to the outer aspects, where the cytotrophoblast is found inner. Both of these structures are associated with the lacuna spaces that forms within these structures that associates with the maternal circulation forming the placenta. The main importance of the placenta is the circulation, the exchange of material that happens between the fetal as well as the maternal circulation. So primarily what would happen, there are enlarged blood vessels that are found in proximity. These get entangled with this lacunar spaces that forms within the syncytial trophoblast as well as the cytotrophoblast, and these are involved in the formation of the placental tissues. Something very important about cytoplasm is that it later, at the end of the second week, with the starting of the third week, it starts formation of certain finger-like projections which are known as villi. So it is not the second week but the third week where the villi formation takes place, so which enhances the development of the placenta and enhances its work as well as the functionality. So again, bilaminar structure formation, the epiblast forming the primitive streak and the primitive node. Then migration of cells starts in the second week, and then the the trilaminar layer forms in the third week, and also the differentiation of the trophoblast to form the syncytial trophoblast and cytotrophoblast. Now you would ask, what would happen to the hyperblast? The hyperblast consists of cells which are somewhat involved in the formation of the structures that are found within the embryo. This includes the yolk sac and the extra embryonic endoderm. So these are the structures that are formed. Extra embryonic endoderm plays an important role in the production of amniotic fluid that surrounds and cushions the developing embryo. So going back to the question, the development of the following structures takes place during the second week of the embryo. So the first one is an embryoblast. A is an embryoblast. The embryoblast is already present in at the second at the initiation of the second week. So it usually embryoblast forms in the first week before the implantation takes place. So this is not a true statement; it's a false. It has happened prior to that of the second week. Amniotic cavity. Yes, the amniotic cavity starts at the second week. Bilaminar germ disc. Again, a true statement. The trophoblast. Trophoblast is something that forms, the structure forms it in the first week. However, later the trophoblast differentiates from the syncytio and the cytotrophoblast in the second week. So this is a false statement. Primary stem villi. Primary stem villi forms in the third week. So again, a false statement. So this is it. The third question. Again, a very important one and a very frequent one that I should add. So we'll be coming back with the fourth question. Thank you.